Hi there, it's Mrs. Lindquist. So today we're going to talk about right triangle trig story problems. So we're going to start off with talking about number one, which is a flagpole. A flagpole is held upright by 30-meter long wires to the ground. If the wires make an angle of 25 degrees to the ground, how high is the flagpole? So I'm going to make this my flagpole. And again, I always start off with making a right triangle. So there's my flagpole. And it says that the wires make a 25-degree angle to the ground. So this is my wire, and this is the ground. So the angle between the wire and the ground is going to be a 25-degree angle. And it's telling you that the wire is 30 meters. So I'll put that in too. That's 30 meters. And the question that they're asking us is how high is the flagpole? So this would be this side here, X. So we need to kind of look at what information we have. We have 25 degrees, and we have the opposite side, and we also have the hypotenuse. So if we look at which trig function goes with opposite and hypotenuse, we can see this is going to be a sine problem. So we're going to do sine of 25 degrees equals opposite over hypotenuse. So in this case, it'll be x over 30. All right, once we have that, we are just going to solve it out. So we'll multiply both sides by 30. So x is going to equal whatever we get when we multiply 30 times sine of 25. Again, make sure you're in degree mode. So x is going to be approximately 12.7, and we should put units on this. So the height of the flagpole is going to be in meters. It's going to be in meters because the wire was in meters. So if the wire is 30 meters, then we can see that the height of our flagpole is going to be 12.7 meters. Okay, number two says a ladder rests against a vertical building. The ladder is 14 feet long and forms an angle of 76.5 degrees with the ground. How far is the bottom of the ladder from the base of the building? So you can see here I drew a right triangle. This becomes my building. So I made a nice little window and a door. It's a very fancy building. And this diagonal line here is going to be my ladder. So I'll just put some steps here so we can see this is the ladder to the top of the building. All right. So the ladder is 14 feet long. So I will label that. That's 14 feet. And it forms an angle of 76.5 degrees with the ground. Well, this is the ground, and this is the ladder. So they're talking about this angle right here would be the 76.5 degrees. How far is the bottom of the ladder from the base of the building? So here's the bottom of the ladder. The base of the building means the bottom of the building. So they're looking for this length here, so across the bottom. So which sides do we have this time? Well, if this is our reference angle, then this would be my adjacent, and the ladder itself is going to be my hypotenuse. So if we think of SOHCAHTOA, adjacent and hypotenuse goes with cosine. It's the ka part of SOHCAHTOA. So we have cosine of 76.5 degrees equals x over 14. So if we want to solve for x, we're going to multiply both sides by 14. And we're going to get x equals 14 times the cosine of 76.5 degrees. So approximately, that's going to come out to be 3.3 feet. Again, make sure you put units on your answer. All right, let's talk about angle of elevation and angle of depression. They're always measured from horizontal. So your line of sight is always going to be looking straight out, horizontal, that's 0 degrees. If you have to look up a certain angle to see a plane, let's say, that would be an angle of elevation. If the person in the plane has to look down that same degree measure to see you, that's an angle of depression. So let's kind of look here. It says the plane spots a person at an angle of depression. So here's your plane, and this is your angle of depression. So this would be angle 1. An angle of elevation from a ship to a person on a cliff. So angle of elevation from the ship would be, this is the outlook of the person on the ship. They have to look up a certain angle to see this guy up here. So that would be angle 4. A person on a plane, a person spots a plane at an angle of elevation. So here's the person looking out, and he spots a plane at an angle of elevation, so he has to look up that many degrees to see the plane. So this would be angle 2. And the last one, a person spots a ship at an angle of depression. So here's the person looking out. He has to look down a certain number of degrees to see the ship. This would be angle 3. So which angles are congruent? If you guessed, angle 1 and angle 2 are congruent, and also angle 3 and angle 4 are congruent. Why are these congruent? Do you guys remember from geometry why these two angles, the green ones, would be congruent? It would be because of alternate interior angles. So alternate interior angles are congruent. So I will finish up the back side of the notes on the next video. All right, see you then.